Welcome back to physics class. Children, so far we studied one by one about the electricity chapter. Means each and every chapter's subtopic we learn, isn't it, children? And it means that the theoretical part has now completed, isn't it? And the easiest part we can say that is completed. Now you people, many people, not only you, means many students feel difficulty while solving the problems in the mainly electricity chapter. So in order to make to you easy, now we will go solving the problems based upon certain topics. Like in today's session we will discuss solving the problems especially on a potential difference, electric current, isn't it, like that. So children, we will start with the first question. How much work is done in moving a charge of 2 coulomb across 2 points having a potential difference of 12 volts? See children, whenever if you are solving any problem, means its related formula should come into your mind, isn't it? Then only you are able to solve that. And also you have to read the question properly, children. You have to understand what are the given things first, isn't it? So after reading this question, what comes in our mind? We should use a formula, isn't it? Then what are the given data? Charge has given, that is 2 coulombs, isn't it? 2 coulombs means here the charge value has given. And the 2 points, it is what? Across 2 points having a potential difference, means voltage, in another words we will refer it as a potential difference. So V has given as a 12 volts. So now what we need to calculate? Work. What are given, children? That is charge Q is equals to 2C, then potential difference, in short I have written, that is, or voltage you can write it as a how much? 12 volts. So work W is equals to how much? So what we have studied, potential difference means what? It is nothing but the amount of a work done in bringing a charge, isn't it, children? So using the formula V is equals to W divided by Q, isn't it, children? We need to use now this formula. To solve this, you have to use this specific formula. The variable W, work value we want. So we can rewrite this equation as a W is equals to V into Q. Isn't it, children? We can write, because when this cross multiplies means V into Q it will become. So now substitute the given values. Substitute the given values. What we will get? W we want to know, so keep it as it is. What is the V value? 12 volts into, what is the Q value? 2C, means 12 2s are 24, and volts into coulomb is nothing but a joules, children. That is how much work has done here? 24 joules of a work or energy has done in bringing a potential difference 12 volts if it have a 2 coulombs of a charge across it. Got it, children? Okay. Now we will move with the second problem. So children, this is quite interesting and little bit different. Different means here the potential difference has given in terms of a 2. I will go step by step, children. First let me read the question. Calculate the work done in moving a charge of 4 coulombs, isn't it, children, from a point at 220 volts to 230 volts. Clearly they are asked that we need to calculate the work done, isn't it? And charge also they have given, that is 4 coulombs, 4C. But the thing is, they told that the potential difference here is how much? 220 volts. And this is, let me take it as a V1, and this is what? V2. That is 230 volts. in bringing this point from here to here, means charge from here to here, how much work has done, that we need to calculate, isn't it, children? So what are the given things, children? Given that is charge q is equals to 4c, then potential difference v. We want to subtract here, children. V2 minus the difference of the voltage is nothing but the total potential difference across it. So V2 minus V1, nothing but what is the V2 value? 230 minus 220 is equals to how much? 10 volts is the potential difference. Got it, children? Now use the same formula. So what we have formula? W is equals to V into Q. W keep it as it is. What is the V value? 10 volts. What is the Q value? 4C. So 10 into 4, 40 joules is the work done in bringing a 4 coulombs of a charge having a potential difference to, that is 10 volts. Got it, children? Okay. Understand? It's a very simple, children. The only main thing you have to keep it in mind, what? First formula, and the given data, so you have to substitute in this formula. Finally, you will get a answer which has asked in the question. Children, the next question comes. How much energy is transferred by a 12-volt power supply to each coulomb of charge which it moves around a circuit? Means here, imagine that this is what? A circuit, isn't it, children? Here battery is there, then it's a closed circuit. Then in order to move the electrons in this circuit, how much energy required they are asking, and the charge they have given it as a each coulomb. The word each coulomb is nothing but a, children, 1 coulomb. Got it, children? Each coulomb means 1, that is Q is equals to 1C, and the energy is nothing but a here the work done, children. W is equals to how much, and which is moves around the circuit, and the voltage is how much here? V is equals to 12V. So V is equals to W divided by Q implies, or directly you can use the formula W is equals to V into Q, and W is what? V into Q means 1C, isn't it? Then 12 joules of energy is required here. Got it, children? Okay, it's a very simple, children. How much energy, in terms of energy is they have asked, means you assume it as a work done, because with the help of the energy only the electrons are moving in the circuit. Got it, children? So you have to use the same formula. And suppose if the question is like, by what other name the unit joule per coulomb is called? Children, you know, joule is an unit of work done, and coulomb is a unit of charge. So what is this unit, joule per coulomb? This slash is nothing but here per coulomb. Got it, children? We know that the potential difference V is equals to W divided by Q, which is nothing but in terms of a unit, how we will write, children? What is the potential difference unit? Volt. Volt is equals to work done is nothing but a joule, and divided by Q means charge, that is its unit is coulomb. So this joule per coulomb is nothing but a volt unit. Got it, children? So the answer is what? Volt. Volt is the unit for that is, it is another name for joule per coulomb. Got it? Now, which device is used to measure potential difference? It's a very easy. What will write, children? Volt meter you have to write, isn't it? How, suppose if it again if they asked one more question, in that means how it has to be connected in a circuit means, remember always the voltmeter should be in a parallel. Got it, children? Suppose instead of a potential difference, that is PD is nothing but a potential difference, instead of PD, if they have asked ammeter, then what you will write? To measure current, isn't it, children? Then its unit, what you will write? Ampere. Like that, all such things related important points should come to your mind. Okay, got it now?